This lesson helps you understand the horizontal asymptotes of rational functions. It's part of a series of lessons about understanding rational functions. From a previous lesson, you learned to understand the vertical asymptotes of rational functions. Vertical asymptotes, or VAs, are the values of the x variable that make the denominator equal to 0. Since division by 0 is not defined in algebra, these are points where the function is not defined. Graphically, VAs are vertical lines at the undefined points. Moving towards the VA, the value of the function increases, and the graph of the function sweeps up or down, becoming infinitely close to the vertical line, but never touching it. In this lesson, you're going to learn to understand what happens to the graphs of rational functions away from their VAs, off to the left and off to the right. In these three examples, the graphs seem to flatten out and become almost horizontal. That's exactly what's happening. They're approaching horizontal asymptotes, or HAs. This lesson explains the first of three rules for horizontal asymptotes. Your understanding of this rule depends upon recalling two important concepts. The first concept is the degree of a polynomial. The degree of a polynomial is the exponent of its leading term, or first term. For the first example, the exponent of the leading term is 2, so the degree of the polynomial is 2. For the second example, the variable does not appear to have an exponent, but remember, it really does have an exponent. It's 1. So the degree of the polynomial is 1. For the third example, the polynomial is the constant 2 and doesn't have a variable or an exponent. A constant has a degree of 0. This is because 2 could be written as 2 times x to the power of 0. And since the exponent is 0, the degree of the constant is 0. Constants always have a degree of 0. The second concept has to do with fractions. It's important that you remember, as you make the denominator of a fraction larger, the value of the fraction gets smaller. For example, here is a list of the fractions from 1 over 1 to 1 over 8. You can see as the denominator gets bigger, the fraction gets smaller. Now back to rational functions. The first rule for horizontal asymptotes says if the degree of the numerator is less than the degree of the denominator, the HA is the horizontal line y equals 0, the x-axis. For example, for this rational function, the numerator is degree 0, and that's less than the denominator, which is degree 1. So the HA is y equals 0. This isn't so hard to understand. As you calculate values of the function moving away from the VA, the denominator gets larger, which makes the value of the function smaller. For example, here are calculations of the function from x equals 5 to x equals 9. Notice as the value of the denominator grows from 1 to 5, the value of the function decreases from 2 to 4/10. So as you move away from the VA, the value of the function gets smaller and closer to 0 to the right and to the left. Here's an automation of the calculation. The value of the function starts at 2, then 1, 0.6, 0.5, and then 0.4. The value of the function gets smaller and closer to 0 from 2 units to only 4/10 of a unit. For this example, the degree of the numerator is 1, and that's less than the degree of the denominator, which is 2. So the HA is y equals 0. But why? Since there is a variable in the numerator and denominator, when x gets very large, both the numerator and denominator get large. So why does the function approach 0? The answer: the denominator has a higher degree than the numerator, so it gets bigger faster and makes the function get smaller and approach 0. To really understand this, here are some calculations of the values of the function. As x increases from 3 to 6, the numerator increases from 6 to 12. However, the denominator increases faster, from 5 to 32. And so the function gets smaller, going from 1.2 to only 0.38. Here's an automation of the calculation, showing the value of the function from x equals 3 to 4 to 5 to 6 to 7 and x equals 8. The value of the function gets smaller and closer to 0, from 1.2 units below the x-axis to only 0.27 units below the x-axis. So, rule number 1 for horizontal asymptotes: when the degree of the numerator is less than the degree of the denominator, the HA is the line y equals 0, the x-axis. The graph of the function gets smaller and closer to 0, off to the left and off to the right. This lesson helped you understand horizontal asymptotes of rational functions. It's part of a series of lessons about understanding rational functions. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.